Hello my dear students, welcome back to my class. In the series of learning data structures, in the previous video we discussed about how to enqueue the item. That is, we saw the enqueue module. Well, in today's video we will discuss about display and dequeue. That is the continuation of the program. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Those who have already subscribed, you need not click on subscribe button. If you are new to my channel, please subscribe to my channel and click on the bell icon. And watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. So here comes the first portion of the program, that what we have already discussed in the previous video. So this is what the for block and the switch block. Assuming we have already performed the enqueue operation. So in the previous video, we have done the enqueue operation and we have dealt with the enqueue function. Any confusion with enqueue, please check out the previous video you have in the playlist. Data structures playlist. Now, we have done with enqueue. Assuming f is in 0 and r has been incremented and it is to the last position, that is 4. So, f means 0, r means 4. Now I'll say, I'll be getting that message as usual. 1 is enqueue, 2 is dequeue, 3 is display. You can also add one more 4 as exit if required. Then you will get a message, enter your choice. Now I'll give the choice as, say, display. Display means I must give 3. The choice should be 3. Then I say CH, switch off CH means switch off 3. So it will come to case 3. I am calling display function. Now I am sending the address of f. Normal variable f. What is the address of f? It is 100. What is the address of r? It is 200. Q, the array name, which will be pointing to the base address. Q is having 400. So here, function call. When a function call is encountered here, the control will be to function definition. I'll come to function definition here. When I come to function definition, I have all these are actual arguments and those are all formal arguments. You all know this, the function concept. Formal arguments, pointer variable f, pointer variable r. Pointer variable f is receiving 100. Pointer variable f is receiving 100. So f is having 100. Pointer variable r is receiving 200. It is 200 means r is receiving 200. And this 400, the base address is received with a new array name which is also Q. It is receiving 400 means it is pointing to this location. Right. So it is pointing to the same array. Q is the array name. It is formal argument. Array name is given as the same Q. You can also change it. You can just have some other name also. So I've taken Q itself. So Q is the implicit pointer. It is acting like implicit pointer. Always you should remember this. Array name always acts as implicit pointer. So it is receiving this address 400 means it is pointing to the base address of the first element. Now, I think all this is done. Now I need to display the elements. So when I want to display the elements, I need to check whether I have elements or not. If the f has been incremented and if it goes out of the array bound, means all the elements have been dequeued. See, when you stand in a queue, the person standing in the first position will go off, the next one, next. And when I go beyond that, there will be no person standing. So the queue is empty. So I need to check that condition. If the queue is empty, then there is nothing to print. So that condition I need to check. So right now in this case, the queue is not empty. I have to display the elements. So I need to check. Let me write the iteration now. So I need to check is pointer f. What is f? Pointer variable f. This is f. See, in the main function also I have taken as f and r, but these are normal variables and local variable to main function. F and r are pointer variables local to subfunction. So f is receiving, it has received 100. Asterisk represents value at the location. F is 100, means it is pointing to 100. Value at 100, it is 0. Is 0, so I need to check, is 0 greater than r, asterisk r. R is pointing to 200. Value at the location 200 is 4. Is 0 greater than 4? No. Condition not satisfied means the front pointer is here itself. I have elements in the queue. Condition not satisfied, come to else block. This block gets executed. I get a message, elements in queue. Then I start with the loop. Let me write the loop iterations. I equal to pointer f. I is equal to value at the location f. Value at the location is 0. Then I say 0. I is 0. Check this. Is 0 less than or equal to value at the location r. R is 200. Value at 200 is 4. Is 0 less than or equal to 4? Yes. Condition true. Get inside and execute the element that what I have in the queue. Q of I. Q of I is what the I value. Q of 0 means in the output I will be getting 10. In the output I will be getting 10. Then look back here only. I plus plus. I gets increased. I becomes how much? It becomes 1. 1 less than or equal to 4. See, these two values I fix up. That's it. Front pointer and rear pointer. Front is, it is initialized once. It becomes 0. Then 0 less than or equal to r. Value at the location r means 4. That we checked. Then I plus plus. I gets increased. Once again check the condition. It is 1. 1 less than or equal to 4. Yes, condition true. Print q of 1. Q of 1. See, f and r are fixed here. F and r are fixed. We are simply traversing the elements. F is 0 only and this is f and this is r. F is 0 and r is 4. So these two are fixed here. So within this bound we are going to print the elements. So 1 less than or equal to 4, I will traverse q of 1, I will print 20. Again loop back, I plus plus, check the condition. It becomes 2. 2 less than or equal to 4, yes. Print q of 2, I will print 30. Then again loop back, I gets increased. It becomes how much? 3. 3 less than or equal to 4, yes. Condition, print q of 3. It is 40. Again loop back, I plus plus, it becomes 4. 4 less than or equal to 4, yes. It is equal to 4. Condition satisfied, print 50. Q of 4. Then again loop back, it becomes 5. 5 less than or equal to 4. Condition not satisfied. Come out of the for loop. Then come out of this display function. I'm back here. I'll say break. When I say break, I'll come out of this switch block, but I'll be inside this for block. So I'll be getting that message once again. Once again, I'll get 1 Enqueue, 2 Dequeue, 3 display. Then enter your choice. The user has to input the choice. Then I'll say after display, I can go with Dequeue. So after displaying the items that what we have in the queue, we can dequeue the elements. So again, once again, we'll get back to the for loop. So after display function, we will get back to the switch block. It is break. Break means I'm going to come out of this switch block, but I'll be inside the for block. Inside infinite for loop, we'll enter. Once again, we'll get all those messages like 1 is Enqueue, 2 is Dequeue, 3 is display. And we will take the choice. Now let us take the choice as Dequeue. So we will input the value as 2. So when we will input the value as 2, the value in the variable ch, the value in the variable ch will be 2. When I say switch off ch means switch off 2. So when I say switch off 2, I'll come to compare with the case value. So it is case 2. Then here comes the function call. So here we have the function call of Dequeue. So here in the Dequeue, we need to pass the reference of the variables front and rear as well as the array, that is queue. So we have the front and rear. So front is 0 and r, it was -1, but after the Enqueue operation, it has incremented and r is now 4. So here f is 0 and r is 4. So what we are doing, we are sending the address of f and address of r. What is the address of f? It is 100. What is the address of r? It is 200. So we are sending 100 and 200, and the array name, that is q, which will be acting as implicit pointer. Just assume the base address is 100, so it will be pointing to this location. So I am passing the array name. Array name will give you the base address. Base address means the address of the first element. So always you should remember this point, that the array name acts as implicit pointer, means it will be pointing to the address of the first element. Assuming the address is 100, so this q is pointing to 100, so I am sending 100. Don't get confused with this 100. You can just, or else you can just change this to 400. So it is 400. Now, so this is the function call. The control will go to the function definition. So again I have the formal arguments. So we have the formal arguments. The name of the formal arguments is the same. If you want, you can change that. So it is f, pointer variable f, pointer variable r, and again the q, which is the array name that has to point to the same location. So once again you will get array name q that is receiving 400, means look at here, it is pointing to the same location. It is pointing to the same location, right? So we have f, which is getting 100, we have r, which is getting 200, and we have q, which is receiving 400. So pointer variable f, this is the actual argument, this is the formal argument. Here also we have the same name as f and r. Don't get confused. F and r is local to this. This is the main function that what we have written, and f and r is local to this subfunction. So we have different memory locations actually. In fact, pointer variable will also have the address, but we need not worry about it. It is a pointer variable, of course. Variable will have its own address, but as it is a pointer variable, it will hold the address of another variable. That is what it is receiving. So pointer variable f is receiving 100, so it is pointing to location 100. Pointer variable r is receiving 200, so I have written 200 here, so it is pointing to the location 200. And the array name implicit pointer q is getting the location 400, means it has to point to this base address, means the same array, right? So here also the q, it is having the same name in the main function. Here also the subfunction we have the same name, that is q, but both are different. Here f and r are normal variables, but here f and r are pointer variables. Q is the name that what I have given in the main function, which is having the base address 400, receiving that base address with one more array name, where that array name is also q, and that q, maybe that q have some address, that implicit pointer will also have its own address, and it is receiving this base address, means it should point to this location 400, means the same array, right? So all these reference, hope you have understood. Now let us get into the function. We have to get into the function now. So we have a local variable which is itm. Now before I start the dequeue operation, I need to check whether the pointer variable f is greater than the pointer variable r. If it is a first dequeue operation, or already dequeue operation is done and the front pointer has already moved forward or not, we need to check. If the front pointer is moved forward, if it is already deleted, if it has already deleted, we have already deleted some items and the pointer has moved forward, means it should be beyond r. So when it goes beyond r, means there is nothing inside the queue. So if the pointer variable f is greater than pointer variable r, it means to say there is nothing to delete in the queue. So let us check the condition now. So let me write the iterations here. Hope you can understand the iterations here. I'll write the iterations here. So now what I'll do, now check is pointer f greater than pointer r. F is 100. Pointer f means value at the location 100. It is 0. Is 0 greater than pointer r. R is 200. Pointing to 200. Value at the location 200 is 4. Is 0 greater than 4? No. Means we have still elements in the queue. So condition not satisfied. So this block will not be executed. I'll come to else block. Else block, what I'll do, I'll say item equal to q of pointer f. What is pointer f? F is pointing to 100. Value at the location pointer f is, value at the location 100 is 0. Q of 0. What is Q of 0? It is 10. That I am storing in ITM. So in ITM I get 10. Then what I do? I say pointer f equal to pointer f plus 1. Pointer f equal to pointer f plus 1. Value at the location f is 100. Pointer f. Pointer indicates value at the location, value at the address. What is the value at this address 100? It is 0. So it is 0 plus 1 means it is 1. So now value at the location f changes to 1. Means now f is not pointing to 0, f is pointing to 1. F is pointing to 1. Then an acknowledgement message saying that 10 is deleted. 10 is deleted. So on the output screen you get a message 10 is deleted. This message you are going to get in the output screen. So this function block is done. So I'll come back to this point. I said break. When I say break means I have to come out of the switch block. But I'll be inside the for block, infinite loop. Once again these messages will be displayed. I'll choose the choice DQ itself. Choice 2. Then I'll come to case 2. Once again DQ. The same thing. 100, 200, 400. But remember, the location 100, the value has been changed. Right? So again pointer F 100, pointer R 200, Q the base address. Now get inside. I say pointer F greater than pointer R. Value at the location F, it is 1 now. What it is? It is 1. So in the next call, the pointer FC it is 1. So 1 greater than 4. Again condition not satisfied. Come to else block. Then I'll say 1 greater than 4. Condition not satisfied. Come to else block. I say item equal to pointer F. So what is pointer F? F is 100. Value at 100, it is 1. What is Q of 1? Q of 1 is 20. So here 20. Then I say pointer F, value at the location F, it is 1. 1 plus 1, it is 2. So now this I need to change to 2. So now pointer F is pointing to 2. F is pointing to 2 now. So it is 1 plus 1, 2. Value at the location F, it is changed to 2 now. Then again a message saying that 20 is deleted. So all these elements has to be DQ'd now. 10 went, 20 went. Then again get back. I said break. Come out of this switch block, but you will be inside the for block. Again those messages will be displayed. You say DQ once again, choice 2 only. Come to this point. Same function call. Come to function definition once again. Now check. See. Value at the location F, it is 2. Is 2 greater than 4? Again condition not satisfied. Then I need to say, come to the else part, say item equal to Q of pointer F. Pointer F means F is pointing to 100, value at location 100 is 2. So what is Q of 2? It is 30 now. Q of 2 is 30. Then I say pointer F, value at the location 100 is 2, 2 plus 1. It is 3. 2 plus 1 it is 3. So that I need to store it into pointer F. So now this has to be changed. It is 3 and now F is 3. Then on the acknowledgement message, then say 30 is deleted. ITM. So values will be changing here. It was 20, now it is 30. ITM means 30 is deleted. Again get back. I say break, come out of the switch, come to the for loop, infinite loop, get inside the infinite loop, again get all those messages, enter your choice, you will take choice 2 only, then switch off choice 2 means again to DQ, once again you call the DQ function. Once again when you call the DQ function, the same function definition. Now, value at the location F, it is 3. Is 3 greater than 4? Condition not satisfied once again. Then I'll come to else block. I say Q of pointer F. F is 100. Pointer F is value at the location 100. It is 3. So it is Q of 3. So what is Q of 3? Q of 3 means it is 40. Q of 3 means 40. Again pointer F equal to pointer F plus 1. Value at the location F, it is 3. 3 plus 1 it is 4. So now it is 4 now. So I need to change this here. It becomes 4 and here also see F is pointing to 4. Then a message saying that 40. So here comes 40. 40 is deleted. 40 is deleted. Function ends. Come here. Break. Come out of the switch block. But you will be inside the for block. Again the messages. Again the choice. Again the same 2 only. Choice 2. Again this function call. Come back here. Now value at the location is 4. Is 4. Check here. Is 4 greater than 4? So all the items will be dequeued, right? Right. So 4 greater than 4? No. 4 is not greater than 4. Condition not satisfied. Come to else block. Again say Q of pointer F. Value at the location F, that is 100. It is 4. What is Q of 4? It is 50. Store that in temporary variable ITM. So now ITM is having 50. Now pointer F equal to pointer F plus 1. F, it is 100. Pointer F means value at the location 100, it is 4. 4 plus 1, it is 5. Now it is beyond the array bound, right? So it is here somewhere else. If I just have the index position, it is 5 means it will be pointing here. So I need to change this. Value at the location, it is 4 plus 1, 5 means F value has to be changed to 5. So F is pointing to 5. Then I will get a message saying that that item is dequeued. 50 is dequeued. 50 is dequeued. Then again come back. Then again break. Come out of the switch block. Get inside the infinite loop. You get that message. Now what I'll do? Once again I'll say dequeue. Just observe, there are no items in the queue now. Once again I'll say dequeue. The choice is 2. Come to case 2. Call dequeue. Again F. Value at the location is 5. Now check the condition. Is 5 greater than 4? 5 greater than 4? Now the condition is true. Condition is true. When the condition becomes true here, F is, pointer F is 5. 5 greater than value at the location R. So R is how much? It is 4. 5 greater than 4. Yes. Condition true. I get a message. Q is empty. And after that there is one more major responsibility of resetting the pointers. I say pointer F, value at the location F. I need to reset. Value at the location F, I need to change to 0. So here it becomes 0 and value at the location R, it should be -1. This is reset operation. So I need to reset the pointer. I'll say return, come back, break. And once again when you go to display and if you try to display the items, so pointer F and pointer R, the pointer R is pointing to -1, then you get the message Q is empty. Then if you take a choice to come out of this switch block, you have to, you can also have one more choice there saying that 4 exit. Then you can put case 4 exit of 0. Just to minimize the lines, I have written default statement. So when you just type any number other than 1, 2, 3, then you will come out of the switch block. And I mean to say when you come out of the default statement here, that is when it is out of 1, 2, 3, some other number you will type. Then it will come to default. I'll say exit. Exit means what? Come out of the program. It will not go. Maybe you may think that you will come out of the switch. No. Exit says you come out of the program itself. So there is no infinite loop there. So you will come out of the program. So this is what with the dequeue algorithm. So that's all for today's video. We will see the execution of this program in the next video. So see you in the next video. Till then, take care. Bye-bye.